Good evening,
Good
everyone.
evening, everyone.
Good evening, Via.
Good evening, Via.
So today
So
we are
today we are
here again
here again
to
to
for a live
for a live
session
session
on process
on
of
process of
innovation,
innovation,
development, and
development.
technology readiness level, commercialization of lab technologies, and tech transfer. So this is a joint event organized by the Startup Club by MCKVIE, Innovation and Entrepreneurship Development Center MCKVIE, and IIC of MCKVIE. And today our speaker is Madam Dr. Debopama Kar Ray. So, Dr. Debopama Kar Ray was born in Kolkata, West Bengal, India on 19th March 1986. She has completed her BTech in Electrical Engineering from Academy of Technology and MTech in Electrical Engineering, Electrical Power from the University of Calcutta in 2012. She was awarded with the PhD Technology from the University of Calcutta in the year 2019. She was awarded with she authored around 31 papers published in international and national journals and conferences with three number of books, chapters, and renowned international publishers. Presently, she is working as an assistant professor in the Department of Electrical Engineering in MCQ Institute of Engineering, Kolkata, with 13 years of combined industry and academic experience. Her special fields of interest include power quality analysis, fault diagnosis, stability analysis, signal analysis, and UAV applications. She is the receiver of Indian Government Award in the year 2021 for her research in traction system. So may I
So may
request
I request
Madam
Madam
to start
to
today's
start
session?
today's session?
Thank you, 𝐓𝐿𝐴𝐻, for a nice introduction of mine. I will be beginning with the session of technology readiness level. I'll first share my PowerPoint presentation, then I'll stop my video, and at the last, we will have an open question answer session. I hope the presentation is visible. Hello.
Yes, ma'am.
Yes, ma'am.
Okay, thank you. Now, good evening, everyone, my colleagues and my students who are presently listening this expert talk. I'll be speaking on the topic process of innovation development and technology readiness level, commercialization of lab technologies and tech transfer. Before going into detail, I want to tell you one thing. See, this is a very big title and very difficult to understand by many people who are not related with this item. First thing is that, what is the topic about? We are actually speaking about how we will proceed with the research, how we can make it in a global level, and how we can commercialize that. That was, we are only talking about the basics of a good research and how we can commercialize that. Before going into detail, excuse me, I must tell you that before starting any research, the first thing is research secrecy. Whatever idea is coming to your mind, first thing, it should be within you. Otherwise, your patent loses. So before starting any type of research or project work, what you are doing with your guide or what you are thinking on your own, which you're wanting to be in the startup, so it should be within your mind and not to be discussed with anybody else. Now coming to what is technology readiness level. It is basically a method which estimates, you can see the points over here. Even if you don't see, you just listen to my words, you'll understand. Because this is a little bit difficult topic, but I will try to make you understand as easier as possible. Technology readiness level is basically a way which estimates the maturity of your research or the maturity of your technology, which was originally developed by NASA in the early 1970s, wherein the key is that you will be thinking of something, you will have to fabricate that. But before fabricating that, you should know what should be the pros and cons of that particular research. And what should the outcome of that if you are actually commercializing that item in the global field. This TRL, technology readiness level, is denoted as TRL, which is having a scale of 1 to 9. And the ninth level is the most proficient level. That means I will show you later on. Firstly, let us understand. When we are in the level 1, means we are actually thinking what to do. As we proceed from 1 to the ninth level, in the ninth level, I am the master of that and I am commercializing that, and I think of starting off my new company, which is called startup or the entrepreneurship, what we say. So ninth level is not always reached by many people. Some people get stuck at 4, 5, and some people reach at 9. And after that, after clearing certain law and orders, they build up their own startup company and they start businessing. But it sounds lucrative, but thing is that when you are wanting to open up your own company, you should think of the profit and loss first. When you are starting any company, 5 to 10 years, when you're working with that product, you cannot expect effective return how much you're expecting. But thing is that after you are learning from your mistakes in the tenure of 5 to 10 years, after that, you can expect the return. So, startup is at the ninth level, whose target is not unachievable. But thing is that you have to have your tenacity to be there for up to a tenure of 10 years so that you can learn from your mistakes and you become master of that one, wherein you can commercialize and you can play your own pitch like that cricket. Now, the US Department of Defense usually started this TRL in the early 2020s, and this 2008, the European Space Agency adopted that. And European Commission, actually, these are the history items. No need to memorize because all these things are available and it is well known by many people who are attached with the research fields. European Commission started this technique in 2010, whose critics were written by the European Union with a title of the journal, Concreteness and Sophistication of the TRL Scale Gradually Diminished as its usage spread outside its original context. I will make you understand this with a very fruitful example. I should tell you, let us suppose, I'm giving you a smallest example. Previously, in our day-to-day life, because I'm a part of electrical, I will try to make you understand with electrical examples. Many of you have read basic electrical and many of you are electricals over here, so they will understand. Otherwise, if you're not in electrical, you will also understand because I'll give an example with the day-to-day usage. Everybody are using single throw switches in your house to make your utilities on and off. But with the advent of time, that single throw switches has been replaced by double throw switches. That means you can see some houses are there in which both sides you can make on off the particular utilities. Even if the double throw switches are been replaced by triple throw switches, which are coming nowadays. So if you are commercializing a product, you must know your cons. That means your mistakes, what you have incurred in designing that one, and the competitors can come to overcome your mistakes. So you must be progressive and you should learn from your own mistakes. We tell it is called self-learning genetic algorithm. Genetic algorithm, many people will be knowing it's an algorithm of solving problems and solving power quality analysis. genetic algorithm, I'll tell you one line nutshell. The algorithm is difficult, but thing is that the algorithm will be starting with the prerequisites, and after the algorithm ends, the algorithm will restart with its own mistakes catered on. That means it will learn from its own mistakes, and the next step, it will be running the algorithm with +1 content, wherein it will automatically nullify its mistakes and it will be much more effective. So whenever you are starting with any work, you should know about your faults, and fault identification of your own is very crucial item. I know everything. That means I know nothing. I know, but these are my mistakes. You have to identify, because whenever you are wanting to do a research, you should know what you can do, what you cannot do, and where you will stuck, and if you at all get stuck, what should be your remedy. And that should be continuously coming to your mind with the advent of time. So this is basically the 1 to 9th level of TRA. You can see this red one, this red portion is consisting of level, beneath is level 1. Sorry. And as you go in the top, you're in the whitish part. 9th means you are the master of that. So what are the definitions as per NASA? It says level 1, basic principles observed and reported. That means you have started the work. Give another example. You might have heard about blind sticks, because MCKVIE had done this project before, and that project was awarded. Blind sticks. I want to develop blind sticks. So how much work has been advanced in that domain? How much work has not been advanced? How much work has been advanced, and what are the pros and cons of particular that? And in which domains work has not at all been processed? This is the literature review. That means you are in the basic level 1. Your next is level 2, concept or application formulated. That means you will define now which formula you will be using to develop your system. Level 3, you have to do experimentations to validate. Level 4, key elements demonstrated in laboratory environments, key elements demonstrated in relevant environments. These two are explicitly different. That means you need to identify what items you should require to fabricate that in the lab, and in what relevant environments you can use that. We have come to level 5. Level 6 means representative of the deliverable demonstrated in relevant environments. That means after you have done the laboratory experimentations, you have made the relevant environment identification of your particular product, you need to demonstrate that in relevant fields, and you need to gain feedback. What can be the possible cons of your design? Next is final development version of the deliverable demonstration. Means you are now much more effective than level 1. You have done your experimentations, you have done your validations, you have talked with different peoples, you have taken much more records from different relevant environments, and you have developed your product, and it is definitely much more fruitful and with less number of cons. And when you want to place that in market, you must do qualified through test. Means I give an example with a very small thing. I have a voltmeter developed in my lab. I want to commercialize that. I cannot commercialize that if I'm not doing the adequate calibration, because error checking is a very fruitful item for any electrical entity to be consumed and for using in the utility applications. So through test is a mandatory item. So before you are doing the commercializations, you should make your equipment through with the adequate calibration so that you can use it in your utility system. And next is operational use of deliverable. Being an engineer, we know two entities, erection and commissioning. Sorry. Erection means, say suppose in your house you have purchased a fluorescent lamp from market and you have placed it in the casing of your house, designated casing. This is erection. Commissioning means you are using it in your day-to-day applications and you have gathered information about how it is working. And commissioning also tells about the lifespan. That means after a certain time you will see that one side of the fluorescent lamp has become dark, it is having a dark ring. We will understand, even if we are not electricals or engineers, we will try to say, oh, this fluorescent lamp it will be out of service in the near future and we have to buy new fluorescent lamps from the market. So operational use and the pros and cons of that will come in the 9th level, when you know everything. You are master of your product which you have already developed, from the literature review to the fabrication level. So these are the 9 levels of the TRL. Next, coming to the responsibilities, contents and stakeholders. So the responsibilities are what? You should do the literature reviews. You should find out what to do. You should compare it with the critical technologies available. Who are your possible competitors? What improvisation they can do or you can do in the advent of time. This should be your responsibilities. And the contents of your TRA will be front matter, what to do. Introduction means its introduction and endeavor overview will automatically give you the literature surveys. System overview, what you want to develop. Assessment overview, what you have developed, you have to assess it. You have to assess the results. You have to validate. You'll conclude with appendices. Because if you want to fabricate, if you have to have a patent, you must show something new, because innovation is the foremost item in these regards. You may have questions that innovation, all time, is it possible? Innovation is possible, but the scale of entities are different. In each case, there is an innovation. We are using fan, this is an innovation. We are using this fluorescent lamp, this was innovated by somebody else years back. But you're using it. Now it is a day-to-day life essential, but it has been innovated by somebody whose patent we are using now, and different companies have just purchased the patent from that person. And we are using it in our day-to-day applications. So what should be the stakeholders of TRA? The producers who will produce, the evaluators who will evaluate that particular entity, the provers who will finally approve that particular item which you have proposed and you have developed. Maintainer, we are the maintainers, because maintainers and users, we are the consumers. So we are using fluorescent lamps, so we are the utility systems, and we are the maintainers and users of this TRA, the named fluorescent lamp, which everybody are using in your day-to-day life applications. Next, coming to the phases. What are the phases of TRA? It is the business strategy. First of all, commercialization involves a business strategy and it involves cost optimization. I give you an example, though it might not be relating you. Okay, everybody has earthing connections in your house with your main switch. We usually say that earth with copper wire, it should be very much effective, but practically we cannot do that, because if you're using perfect pure copper, we cannot afford the costing. So we are going for the mixed alloys for the construction of the wires. So simple as that. Business strategy means you need to have your product, you need to marketize that, and you should be well aware of your competitors and what amount of cost optimization they are providing. And you should initiate that in your construction. You should give a very effective delivery and consumer specific delivery, and the usage must be, the long usage should be your mode of concern. We sometimes call it payback period. You are giving it and you are getting a return. So whenever a consumer will buy an entity from you, they will be concerning about the payback period, how much number of years that particular entity will work. So if you can increase the payback period, right, so you can get effective results from that with the least error analysis. Retirement means your product will now, it has to be stopped because it has already reached the payback period. It has overcome the payback period and it has to be stopped, and new entity has to be purchased and used. So what are the preconditions? Initiation phase is started, means you have thought about something and you have started the process of building that thing and gifting that thing to the real world. And you have to first define an architecture team with a specialized number of peoples who will be doing this entire work. And what are the inputs of TRA? The work procedure, how you proceed the work, and how you interact with the stakeholders and you get permission and approval from the necessary stakeholders. So what is the guideline? Many things are written over here. Two items are highlighted: immature technology, critical technology. I'll make you understand this with a very easier example. Two persons are there who are intending to pursue research. One person is doing the literature review in Wikipedia and the other person is doing the literature review in IEEE. So definitely the person doing literature review in Wikipedia will be a foolish entity rather than a person doing literature review in IEEE. That means before starting anything, you need to do literature review, and that must be from a reliable source. This is the first and foremost guideline before starting with any objective with which you are fascinated. So, first thing, start your review from the reliable sources. I can name you some: IEEE, IET, Springer, Teller and Francis, Nature's, and all that. Depending on your research area, you should identify who are the potential source of your literature review. Once you have identified the potential sources, you should start your literature review from that only, not your Wikipedia, because I just want to tell you this Wikipedia or something like that. Anyone can write anything and anyone can delete. So the credentials of Wikipedia is very much risky. So whenever, it is my request to everyone who are listening to my talk over here, if you are aspiring to do a research, please try to do the initial literature reviews from sourced publishers. That means renowned publishers. Then only you will identify and you will define what to do, what not to do, in which domain work has been proceeded, in which domain work has not yet been proceeded, and you can do what in what domain. It is only possible if you're doing it for a very renowned publisher. Now, this is the level. New critical technology. So theory must be there. The technology will be envisioned. The proof of the concepts will exist in those critical technology. Demonstration of lab technologies pertaining to that topic will be there. Integration tests will be passed, means tests and rigorous tests and analysis will be passed before that particular item was published. System tests were passed, alpha test, beta test, all these things are rigorous. These are name of the tests. Don't think that these are the certain entities. These are not that. Suppose I want to fabricate something in my consumer area, I'll be calibrating that. I'll be error checking that particular entity. I will be making my self-learning process to make it as much as accurate as possible. I need to reduce the frictional error of a particular rotating item. I need to reduce the magnetic circuit error of that particular entity. So all these are the system tests, alpha test, beta test. They are naming this thing. These are not different one. Likewise, this. And after all tests are passed, you'll be doing the first operational test, and you will identify how much error is there. In voltmeters, it is already written. The error part is already declared in the spec chart. Some voltmeters, high spec voltmeters, it has already been given. And after all the error checking and all the fabrications have been done, we are giving the successful product uses, means we are dispatching our item. So these are the levels of the technology readiness in the new critical technology. And you can see the reused critical technology. If you are having your effective item delivered with least operational error, with the least modification, you can reuse it. And that comes around the reused critical technology. Next, coming to, according to DoD USA, what are the key players, process and the submitting of a TRA? So what are the key players? You need to define the milestone. There must be a program manager according to DoD USA. There must be an assistant secretary of defense because this is a defense part. There will be a team deployed with the subject matter experts called SME. They will do the necessary work. That means there will be a program manager, there will be an assistant secretary, there will be team of experts. In this expert team, any one of you can be a member because it is your mind rush and you are the startup of that particular idea. So what you'll have to do, process of conducting, establish the TRA plan and schedule. That means you have to plan and you have to give it to the higher management. What is your plan? What you want to do? And what is the tentative schedule? In how much tenure? I give you an example. How much tenure? Say after 1 year, 2 year, how much number of years you require to fabricate that? Your SME team must be formed. Your technologies must be assessed. First of all, identified and assessed. You should collect mature data from the day-to-day life or from industry or from potential sources to identify at what time you will be able to mature your product. You have to assess your maturity level. You have to assess your team. And we normally say you build a team such that you don't have interquarrels among that. So this is the mandatory thing in SMEs here. SME team assessment is also a mandatory item because I'm thinking of something and I'm not having a very good rapport with my teammates. I cannot fabricate the product. So you should choose your team in such a way that all are working at the same pace. And next is prepare, coordinate, and submit the TRA report. That means prepare. How will you prepare? I told you. First, you will do the reviews. Then you'll do the laboratory experimentations. Then you will do experimentations relating with what others are doing. You'll identify your pros and cons. You will tend to reduce your cons. You tend to marketalize your product, reducing the error and increasing your efficiency. And lastly, review and evaluation. After review and evaluation is complete for your thing, so you will submit your TRA. The skeleton is okay. You'll submit it. Once it gets passed, you can use it. You can commercialize that depending on the necessary cost optimization and other entities in your concern are getting fulfilled to sustain in the market. This milestones are given here. See, it is already written. Some entities are defined. CDD, Capabilities Development Document. CTE, critical technology element. All this I'm not reiterating, it is already written over here. So 3 milestones you'll have to achieve. First milestone is understanding. Second milestone B, all things written over here, you can read it. I'm not reading the slide, I'm only telling you the nutshell of that. Milestone A, how will you reach? What to do? What has to be done? What are the necessary items which has to be pondered? These are coming to the milestone A. Milestone B means you are doing the work, you are doing the necessary laboratory experimentations. And milestone C, you have done all your error checkings and you are in the final 9th level of your TRE. So these are the 3 milestones of your application in TRE. So again, the definitions are given. No need to ponder it because I have already given this definition pertaining to the previous slide here. Similar thing has been given here because I was talking about milestones, so I have given it again in the 10th slide. So this is the hierarchy. These are the steps. That means this is the staircase to reach the 9th level. You can see the first 3 levels are basically the conceptualized levels. 4, 5, 6, 7, 8, 9 are the working levels wherein you will be doing the experimentations, you'll be doing the validations, you'll be doing the error checking, you'll be doing the relevant comparative study with your product and the neighboring ones, and you will do the necessary comparative study and all that. And after you reach the 9th level, you are ready to deliver your product to the market. So you are in the commercialized level. And now you can start your own startup. But I told you before, you have reached the 9th level. It may be easier for you, but starting your own company is not so much easy. It is lucrative. It is no doubt lucrative, but if you have patience for 5 to 10 years, many people are there who are having patience and have become millionaires after 10 years. I want to tell you that everybody will be a millionaire and having crores of rupees and millions of rupees in your bank account. The thing is that whenever you are starting a startup, you should have the patience and you should learn from your mistakes in the initial years. Then only you can excel after that particular tenure, which is called gap. So it can only be done after you have reached the 9th level. You know your product, you know the necessary law and orders of that, or you want to file a patent to the government. I must tell you that getting an India patent is a little bit time consuming, and getting an international patent is easier because the international patent usually it is awarded in 6 months to 1 year, but in Indian patents are usually given in 2 to 3 years. So if you are thinking for patenting, if you go for international patents, it will be less time consuming. So this is the staircase of the TRL, how you will do the thing, and you are where in what level. 9th means you are at the top level, you know everything of your product. So it is again same thing in a different domain. So the basic concepts sub-index means you are doing everything in a learner level. The middle branch, you are having all your experimentations, all your error checkings, all your comparative study in the bridging domain. In the final, you have done everything, you know everything of your product, and you are in the final level, you are commercializing that. So this is a global competitive index. Now technology transfer. What are the levels? Level of capacities required, national policy level, institutional level. So whenever you are transferring your tech, and so before having your own startup or before you want to file a patent, some legal issues are there where from permissions has to be taken and lawyers are involved in that part. for the intellectual property rights assessing, and the lawyers will do the necessary works which the technologists don't know usually. Say suppose you have developed a patent on a certain entity, you want to file it up there, you will write only the technological aspect. The lawyers will do the IPR survey and they will be giving you the law and order part. Then only that has to be clubbed with your work and that has to be filed for a patent. So this is the national policy level or the institutional policy level, whatever you're working with. So, or company policy level, and you have to work with a particular lawyer who will write your technological survey in terms of the law and orders, and your patent or your startup will be complete. So, how will you identify the CTE? CTE, I go back to make you remind, CTE is critical technology element. That means, what is the work which has incited you to just start your particular survey? So, first of all, establish your TRA, what you want to do. Then, review the team, review the candidates involved in the CTE, and check that there is good interpersonal relationships among the CTE team, and find out there is a very sound coordination amongst the teams, collect evidence from the team, and you just start your process. Next, coming to assess CTE readiness. That means now you will submit a TRA report. The CTE maturity, how can it be assessed? Interpersonal relationship is very sound. They have worked on the same domain. They have prepared the data. They have coordinated that. They have done the necessary error checking. They have done the necessary calibration. I'm telling you in electrical point of view. And they have submitted the report. And that has gone for review and evaluation by the policyholders and by the higher authorities. So this is assessing CTE readiness. So process and practices for identifying CTEs. Step 1, create an initial list of possible CTEs. There must be n number of peoples. All are not having the potentiality to do something. So you need to identify who are the potential entities who can do that work. So identify CTE, develop the potential candidate list who can do the work, and start the coordination process. And in which domains they will work in the physical environment, they will do the logical reasoning, they will do the data analysis, they will do the security analysis and error checking, and they will make it usable by the consumers at the ultimate end. So this is the environment defining after identifying of the CTEs. This is a block diagram which will tell you. This may sound very much critical, but it is nothing but just like a genetic algorithm self-learning. Forget about genetic algorithm. I give an example with a person. A person, whenever that person is speaking, he or she is not knowing how she is looking to the audience, how she is visible to the audience. Whenever that person will speak in front of a mirror, he or she will understand what physics issue he or she is having while speaking. Some people shake their hands frequently while speaking. Some people shake their head much while speaking. Those are mannerisms. So whenever you learn from your mistakes, you become expert of that. This concept is nothing but the concept of CTE, which it has been given here. So the process input is known. What I want to do is my process input. Requirement analysis means what are the prerequisites which are required to make my dream a success. Next is functional analysis and allocation. What I need to do, what are the entities which has to be used, what entities which has to be deleted, what has been done,
what has not been done, in which domain errors has been received, in which domain there should not be any error, and what should be the effective design, which is in the functional analysis. The system analysis and control, that means you are fabricating that, you are maintaining balance, and you are designing your item, and you're having the expected synthesis. The first flow is over. In the first flow, what errors has been incurred is again entered into the verification part, into the requirement analysis. That means the technique is itself making the system learn about the mistakes, and it is running in the second step with the mistakes in the first step nullified. So this is self-learning process, just like self-learning algorithm or self-learning person who learn from their mistakes. So this is just like a block diagram which is given over here for the context of identifying the CTs. And finally, when in the loop all the errors are nullified, you are getting the process output, and this process output is nothing but your developed product which you want to commercialize in the global field. Next, coming to the functional architecture, we have functional architecture and physical architecture. That means I told you before, functional architecture, all the technicalities related with your topic. And lastly, the physical design and fabrication will be the ultimate function of the CTs. And what are the system engineering concept for identifying the CTs? See, it is written, the DoD architecture framework has technical standards. That means the OV, your operational view, identifies what need is there, how the system, point 2, how the system will be operational, and what technical standards it has to meet. So 3 entities are very much effective. First thing, what I want to do, whether it is accomplished, whether it is eligible for work, and third one, whether it is meeting with the standards defined by any country. No need to memorize with the technical standards, because whenever we are doing a design, we have design books for that. In electrical point of view, we have IEC, we have Indian Electricity Act. So whenever we are doing a design on electricals, I give an example with electricals because I am a part of electrical. It is also in thermals, you have design parts. So these design perspectives, no need to memorize. Some values are there pertaining to a particular standard which you need to use while fabricating your record. So technical standards will be with you, and you will only check whether your design and your work is meeting with the regulatory standards defined by the government of India, or if you're abroad, government of XYZ countries, that will be given to you. So this is basically the, and when you are at the top, operational view at the top of that, which is a junction of this blue, yellow and red color, you are able to achieve everything and you have your product in your hand. So this is the 3D view of whatever has been given in the block diagram here. Now these are the some annotations. How will the designer build? This is a pictographic nature. It is not related with all the cases you will be having that. It is with respect to DODAF perspective. If you're designing for a different entity, your chart will be different. I have shown only with you DODAF perspective. Now, again the same thing. How maturation planning process is usually undertaken. Firstly, you will be identifying your technology readiness. That means that your issue is given to you. Now,
what issue is given to you, you will be doing the functional analysis and the requirement analysis of that. This involves a vivid literature study of what you want to do. In what domain you need to work. You need to do the fabrication and first order risk evaluation. If in the first order risk evaluation you have least risk, your path will be in that direction. Let us see, it is given negotiable risk means this is your current path of your work. If there is a relative higher amount of risk, you need to develop alternative paths for that and you have to restart your work. If in the first order risk analysis you have availed a particular amount of risk which is beyond the tolerable limit, even if you work on the same domain, you are a bullshit and you will never reach to the ultimate goal at the end of that work. So after doing the error checking, if the error percentage is beyond the tolerable limit, you should find out alternative way to reach your goal. And in the alternative way also, you should make the decision process, you should make the error checking, and after that, you should give a effective summary and work plan. If your design is foolproof, you can start from the current path, and in the current path only you can submit your TMP summary and work plan. If in the first path, in the first step, you incur error, you have to come down with relative checking, and at the last end, you will be giving your TMP summary. So, what are the requirements of technology transfer and commercialization process? First thing is research. And before starting any effective research, the first thing is that research secrecy. Whatever you are thinking in your mind, you can tell everybody the topic, but not the exact one in which you want to fabricate your data. So, research has to be within you. The insight of research must be within you. That should not be discussed with XYZ peoples, because in research, copying or plagiarism is a very effective identity. Nowadays, everything what you submit, you cannot copy from that and publish papers and patents, because once you are submitting any entity to any renowned publisher, they do the online plag check. And rule is that if your plagiarism report is beyond 10%, you get rejected by renowned publishers. And you'll not have to pay for that for publishing. For patenting, there certain amount of money is there, depending on how much consistency and where you are submitting with what work. It is depending on that. Also, the law and order levels, you need to pay something. In startups, you need to pay something before you are want to publish. Other than me, I will not discuss with somebody else, and I will start my work. I can take suggestions. I will start my work, and I will try to reach the goal. Second is pre-disclosure. Pre-disclosure means I am doing a particular work in a particular domain. Sorry. And I have got the pros and cons of that. And before starting with my work, I know what will be the necessary hazards which I will be facing while proceeding with this work, which is pre-disclosure. Invention disclosure, which you will have to disclose while doing that work in your particular team. That means research insight must be within your team and it should not go beyond the jurisdiction of the team. Then you will have your assessment in relevant domains. Data protection must be there. Data Protection Act is there. Whenever we take data from a certified entity, after publishing our patent or research paper, we need to acknowledge that. And if we don't acknowledge, and if that particular data provider finds after a certain time that we have taken data from that person and we have published it without the consent of that particular person and not acknowledge that in the paper or patent, it can be a law and order issue. So be very cautious when you are copying data or you're taking data from a particular entity. You need to acknowledge that, because certain patents and certain journals are there. We usually take the effective data of the supplier from which we usually take records from the industry. Next is marketing of a product and licensing. If you want to open up a startup, you should have your own license, consumer license and product license. So I want to build up a startup company of my own. So what are the fee incurred with that? And opening up a startup company is a dream of many people. You should be master of your knowledge. You have a product of your own. After a certain number of years, you will be successful. There are certain bullshit startups which don't do the effective literature reviews and they fail after opening the startup company. I'm not talking about that. If you want to be a very efficient businessman in the startup field, thing is that you are successful means you know the pros and cons of that. After a certain lock-in period, called in business we call it lock-in period, say 5 to 10 years is a lock-in period of your work, and after that 10-year of a lock-in period you are getting the return, which is your particular benefit. So you have to take the tenacity, you have to be effectively engaged within your work, and you have to know your competitors to survive in the market. So what are the fees? It is upfront license fee, industry standard royalty rates, minimum annual rate royalty, sub license fees. All these things you have to pay before typically starting a startup. And license management, because license has to be renewed after a certain period of time. Product development has to be effectively commercialized, and product development improvisation has to be made. I give you an example with day-to-day life. Everybody has in your house fluorescent lamps, and fluorescent lamps, the earlier design was circular, just like a cylindrical rod. Now it is square. Everybody has seen, somebody has seen probably, the fluorescent lamp is square now. Previously the lamps were circular in nature. So these are improvisations which you have to do if you're opening a startup company and you are doing the commercialization necessarily, and you are knowing what the competitors are advancing so that you can sustain in the market. So thank you all. I'm end up with my presentations. If you have any questions, you can ask me. I'm stopping the presentations and I'm just opening my video.
Thank you, ma'am. It was
Thank you,
a
ma'am. It was
great
a
session.
great session.
So yeah, it is
So yeah,
open for all
it
the
is open for all
participants.
the participants.
If you want to ask
If you
any
want to
questions,
ask any questions,
you can ask to ma'am.
you can ask to ma'am.
Ma'am, I have a
Ma'am, I
question.
have a question.
That
Yeah.
is,
That is,
you specified
you
on maintaining
specified
the
on maintaining the
research
research
secrecy,
secrecy,
but
but
in a part of a
in a
startup,
part of a
after the
startup, after
idea
the
has been
idea has been
established,
established,
when people
when
approach
people
for
approach for
investment,
investment,
so they need
so
to
they
share
need to
their
share
idea.
their idea.
They may have
They may
patented
have
the idea and
patented
they
the
are
idea and
presenting
they
it
are
to the
presenting it to
investor.
the investor.
But even
But
during that
even during
time,
that
there is
time,
a high
there is a
chance
high
of the
chance of
idea
the
being
idea
copied,
being copied,
because the
because
potential
the
investor
potential investor
has
has
better resources
better
than the
resources
person who
than
is
the person who is
presenting it.
presenting it.
So,
So,
how can the
how
person
can the
protect
person
his or her
protect his or
idea
her idea
during this phase
during this
when
phase
he or
when
she is
he or
looking
she
for
is looking for
investment and it is
investment and it is
presenting to other
presenting to
people?
other people?
Yeah. See, a very effective question. See, I have my research and I have developed a product of my own. The investors are interested in my product. They've approached me and they are wanting the designs of that. Even if the investors are connected with other people who are working in the same domain, if they copy that, that will not be an innovation. But thing is that what I want to ponder, that is not at all new innovation. That is in copying of that. And even if they copy, what they will tend to do, they will tend to minimize the cost such that the investor is interested in them. But whenever you will disclose your research secrecy, don't disclose the critical entity which you have undergone while fabricating the final level. At least you have to keep secret and patent on that which is not deliverable to somebody else. Whenever you are designing and giving it to the people, we usually give it in block diagrams. Stop sending them the programming. Stop sending them the crucial standard values. There are improvisation in the standards which also been done while commercializing a product. Stop sending them what value we have taken while commercializing, what value you have taken in final design. You have to have certain secrecy which should be within you and not to be disclosed with other people's. Otherwise, you cannot stop copying because they will take, even if there is no innovation, they will tend to compete with you with the least cost. And the investors will be attracted with those designers or those commercial products which are less costly. So, have you understood, Anushka, what I mean? You have to
Yes,
have
ma'am, I
within
have
you
understood.
certain secrecy
Hmm.
which you will not discuss with anybody else. That is your own patent. It is coming from your gray matter of your mind, and that should be within you. Anybody wanting to proceed have to ask that from you to proceed in that domain. Otherwise, your royalty loses. Understood?
Yes, ma'am.
Hello. Yes, ma'am.
Yes, ma'am. And
Yes, ma'am. And
in the members
in the
of this group
members of this
also,
group
like,
also,
is
like,
signing
is
an NDA
signing
sufficient?
NDA sufficient?
Like,
What? Like,
how do we make
how
sure
do we
that the
make
team
sure that
members
the
are
team
also
members are also
abiding by that
abiding by
secrecy?
that secrecy? See, it is manhandling. It is nothing but manhandling. See, I cannot say always that the person working with me is very much effective and will be very much loyal to my work. I cannot ensure. The thing is that whenever you are working with a particular list of peoples, you should read their faces. As you are becoming experienced, you will be able to read their faces. You will be able to read their inner core, and this is called manhandling. Whenever you are working with a team, even if all of you are dedicated and all of you are committed to the same work, there can be one person who is not loyal. So you have to identify them from the manhandling and from the face reading and the activity list of that person in that particular team. There is no thumb rule of that. You have to identify depending on the insights and the work they are pursuing. So this is called manhandling. You have to do that. If you're wanting to be a very good researcher and if you want to file a patent, you're working in a group, you have to have the manhandling.
Okay, ma'am.
Okay, ma'am. Any more questions? Any more questions? See, it is an online interactive forum. If you've understood, then even if there is any misunderstanding of the topics, you can ask me because it is completely newer concept and it is not related with your day-to-day studies. And we are here for a good research or for a good patent or for opening up a startup company for starting our entrepreneurship. I think the audience are not having any questions. So if everybody is satisfied with the presentation, we can stop off with the session.
Yes, 𝐓𝐿𝐴𝐻𝐿.
So, may I request our Sudeep Samanta sir, the coordinator of the event, to show the vote of thanks.
Hello, am I audible?
Yes, audible, you are audible.
Yes, good evening, everyone. Myself, Mr. Sudeep Samanta, and I am here to present the vote of thanks for today's webinar. At first, I would like to thank our speaker, Dr. Debopama Kar Ray, for enlightening us with her knowledge and delivering such a good presentation. Thank you, madam. And actually, that today's webinar was full of knowledge and interesting things. I think it gave the deep insight into the topics and also revealed some interesting facts. And I am pretty sure that the precious knowledge delivered by madam will definitely help you to make ready to adopt the new technology. And I would also like to thank our principal sir, Professor 𝐓𝐻𝐿𝐴𝐻𝐿 Lahiri, for giving permission to organize this webinar session. And also I would like to thank our IIC MCKVIE President, Dr. Prashanjit Chatterjee, Vice President Sir, Professor Amit Fadikar, and Convener Dr. Joydeep Banerjee for inspiring us always to organize this kind of webinars. And I want to thank all of the student committee members, especially Anushka from ECE final years and Shobuj from electrical third years, who really worked hard to make this event successful. And finally, I am very much thankful to all the IIC members, all the startup club members, and innovation and entrepreneurship development center members of MCKVIE, and all the audience here present for listening this valuable speech. So thank you everyone. The feedback link is given in the inbox. So please fill up it within 15 minutes and then you will get the certificate link. Thank you all.
Thank you, sir. So with this, today, here we come to the end of this wonderful session. And we hope you to meet all in the more upcoming events.